Hello guys, so in the last video we learned how to create a PDF chatbot using Langchain and OpenAI. So today in this video we are going to learn about PDF chatbots using Langchain and Google Gemini. So Google Gemini is free for developers as of now to up to a certain usage. So you can for personal usage to learn about RAG systems and to create RAG systems you can try it out. It's free up to a certain limit. So I'll show it to you. So you can go to aistudio.google and create your API key just like I've created here, and then see in the pricing part you can see that that Google 1.5 Flash is available free up to 1500 requests per day. So that's a fairly good amount of requests that you can do on a personal machine. Or if you want to go for Pro also, so Pro also has 50 requests per day. So if you want to build any RAG systems, this is the best case scenario that you can use. Okay, so let's go back to our Gemini code. So Gemini, again I'll put this GitHub repo in the description. You can just copy it from there and pull the code. Okay, so I have written how to do it out here. So the dependencies are mentioned, and we need to set up an environment env, and wherein you need to put your Google API key. Okay, the rest of them are all of them are same thing, so I'll just go through the code as of now. So yeah, let's clear the file. Okay, so yeah, so in the similar way that we have created last time, so I've created a virtual environment, Gemini env. In Gemini env, I've installed all the requirements or whatever that is required for this thing. So you can just do pip install -r requirements.txt and everything will be installed. Okay, and so let's come back to our RAG problem. So in the RAG, what we do is basically we take up a particular PDF file, and then that PDF is extracted, and then it is broken into chunks, and we will save those extracted things into a vector embedding. So in vector embedding, what we do is we'll need to pull that out. So we need to retrieve it out. So using similarity search, we will retrieve the chunks from there with top 5 similar chunks or top 10 depending upon your use case that you have. In certain scenarios you may have to pull up more chunks. So depending upon your use case, you need to pull up the chunks from there. Those similar chunks will be then fed to your Gemini or any other model, LLM model, and from that model the model will give you the final answer. Okay, so let's see how we have done out here. So here is our main function. So what we have done is we have taken the Reliance annual report as our input PDF, and that PDF is first loaded. Okay, and then we'll split the documents, then we'll create a vector store. After vector store creation, we'll create a question answer chain using Langchain, and then we'll invoke that chain. We'll pass on the query part there, and we'll try to find the similar queries, and we'll find the final answer from the Gemini. Okay, so let's look into each and every function that we have created. So just like the previous day, what we have done is we have created a load PDF function. So in the load PDF, using PyPDF loader, we are extracting the PDF documents and returning the documents. Okay, so using PyPDF loader, which we have imported before, that we have imported here. Okay, now after you import this thing, what we do is we split the documents. Okay, so splitting the documents again has some you need to mention the chunk size in which you want to split the documents. Okay, so here we have mentioned a chunk size of 1000 and chunk overlap of 200. So chunk size I have mentioned little bit on the higher side, because Gemini has a context, like an input context of depending upon the Gemini model that you will take. In certain scenarios it is 1 million, and in certain scenarios it is up to 2 million also. So you have you can directly pass the PDFs also to Gemini, but it's better to have a chunk size so that everything is optimized. Okay. So using that same recursive character text splitter, we'll split the text, okay, and we'll send the documents, we'll send the chunks here. Now after our splitting is done, we'll create the vector store. Okay. So in the vector store, we will using ChromaDB again. We'll store. First, we will pass them through the embeddings. So embeddings, basically what we do is we can't directly store the text part. So we store them in numbers. So this Google generative AI embeddings, this model will turn it into numbers. It will turn them into certain embeddings. Those embeddings will those embeddings will be stored in the your vector DB, that is ChromaDB out here. You can use any other Google has AlloyDB also, and if you are using Vertex AI, so in AlloyDB you can store your vectors, and then we'll invoke the QA chain. So we'll create a QA chain and then invoke. So let's go to the QA chain. So in this QA chain, what we are doing, last time we didn't give us the temperature and all those things. So temperature will first initiate the LLM. So while initiating the LLM, we are also mentioning the temperature. So temperature here we have mentioned is 0.1. You can mention 0 also, it depends on you, and with the model that we are taking is Gemini 1.5 Pro latest. So the more temperature is towards 0, the model will not hallucinate. So the once you start giving its temperature more than 0.5, 0.6 and so, then your LLM will start hallucinating. So model values also we are taking maximum output tokens also I've increased out here, because these has higher output in Gemini, there is not an issue. So again, then we are creating a retriever. So the retriever search type is similarity. We'll do a similarity search, and we'll return the K, that is the number of documents that we are going to return. So we are going to return five chunks out here. So previously in the previous video we did 3 chunks because context size of OpenAI is on the lesser side, but here we could have taken 10 also, but for this scenario we have taken only 5. So what will happen is we will have 5 query 5 chunks returned after similarity search. Then we will send it to LLM again. Those we'll send our initial query plus this 5 chunks to the LLM, and LLM will then ground its truth based on those 5 chunks only. It will not try to hallucinate from outside, just because this annual report might not be a knowledge to the Gemini. So what it will do is it will go through those 5 chunks and see whether our query is present there in that chunk or not. Okay, and then it will give us the answer. Okay, and we are returning the source documents also. So I'll just run the so source documents again. We are just trying to find out the pages and the content. We are printing the pages and the content also here. So let's run the code here. So basically what we will do, python rag.py. It takes certain time, so what it will do is it will extract the document. Document is a little bit bigger, and then it will after that it will do a chunking, and then it will store in the vector database also. So that's why it takes a little bit time, 1 or it will take I think 30 seconds to 1 minute, or maybe a little bit more depending. I will see how much time it takes. Okay, so this is how it is, and in the meanwhile we can see the code here also. So what we can do is you can copy this thing and try it out. So put whatever code I have put there. Like, you can copy it from here and use it yourself. Just you need to create a .env file and everything will be running. And the Google AI Studio is free for everyone. So let's see whether it has run or not. Well, still now it's waiting. So let's wait for certain seconds, and I hope we will be okay to go ahead. Yeah, it's taking some time, but yeah, this is yeah, we have got the answer now. So we'll see what we have got. So the query that I have asked here was, what is the annual revenue of the company for the last 2 years? Okay, so let's see whether we got the answer or not. Yeah, so the company's standalone revenue for the from operations was 3 lakh something crores in 2023-24, and this in the 22-23. Additionally, the company had other income that also it has captured. Okay, so that it is also calculating the total standalone income and for both the scenarios, and giving us the source documents also from which pages it has got. So page number 90 it has got, and again if you go down, page 48 is another page 112, page 67. So these are the, like, this is how you can just go and create your own RAG system. And this is something for practice. Like, right now we are not using any re-ranking approach or anything. We can try to change different models, based on your use case, and then you can try different chunks also. And in the next coming set of videos, what we will do, we will try to see how we will evaluate a RAG. You can create a PDF chatbot, but you don't know whether you can evaluate, how do you evaluate? You don't have accuracy metrics out here defined, right? Predefined. So there are certain open source tools that we will use, and we will create these things. Okay, so I hope you have liked this video. Go and try it out on your own computer, and then we will say, okay, if you have any problems, do comment it out here, and do like, share and subscribe my channel. Thank you very much.